So far, in theoretical probability, we've been looking at listing outcomes to calculate the probability of one-step events, such as getting a heads if we flip a coin. However, there are many times that we want to calculate the probability of events that have two or more steps. And tree diagrams is one thing that can help us achieve this. So, let's begin. So let's consider the situation where we flip a coin twice consecutively and we want to know before we begin what the probability of us getting two heads in a row is. Well, if we begin by listing the outcomes of the first flip of the coin, we can write this that we could either get a heads or a tails. Now on the second flip, if we were to get our heads on our first flip, the potential outcomes that we could get is either another head or a tail. However, if we got a tails on our first flip, the potential outcomes that we could get is a heads or another tails. Now, how I've represented this is what we call a tree diagram. It starts with the outcomes here of the first event, and then it starts branching out to the potential outcomes of any subsequent event. So if we wanted to now know what all our potential outcomes are, we start here and continue along our branch. So our first potential outcome would be a heads followed by another head. Here it would be a head followed by a tail. Here it would be a tail followed by a head, and here it would be a tail followed by another tail. And we now have a list of all the potential outcomes we could have from flipping a coin. So what if I now wanted to know the probability of getting two consecutive heads from flipping the coin twice? Well, I need to start by identifying the successful outcomes within my potential outcomes. So this successful outcome here is two heads. A head's tail isn't, a tail's head isn't, and two tails isn't. So I only have one successful outcome listed here. My total outcomes here is going to be 1, 2, 3, 4. So I've got 4 total outcomes. So if I now want to work out what the probability is of getting two consecutive heads, that's going to be a 1 in 4 chance, represented here as a fraction. So what if I began by rolling a normal 6-sided die and then flipped a normal 2-sided coin? What would be the probability of me rolling an even number followed by flipping a head on the coin? Well, to do that, we begin by drawing a tree diagram. Now, I've already completed a tree diagram where I began by listing all the outcomes that I could get from rolling that die the first time, which would be 1 through to 6. So then I considered, if I rolled a 1 on that first try and flipped a coin, the potential outcomes that I could get would either be a heads or a tails. And I continued to do this for each one of the first outcomes. So now we've got our tree diagram, let's begin by listing all our potential outcomes. The first of which would be rolling a 1 followed by a head, then rolling a 1 followed by a tail, rolling a 2 followed by a head, rolling a 2 followed by a tail, a 3, then a head, then a 3 followed by a tail, rolling a 4 and a head, a 4 and a tail, a 5 and a head, a 5 and a tail, then finally rolling a 6 and a head and a 6 and a tail. So let's bring in our probability question now, where I want to know what the chances are of rolling an even and getting a head on our coin. So let's begin by counting the successful outcomes for our scenario, where a successful outcome is an even and a head, so there's our first, an even and a head, so that's 2, and then another even and a head, so we've got 3 successful outcomes in this situation. The total number of outcomes is the total potential outcomes we've got here. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have 12 total outcomes. The probability of getting an even and a head is going to be the successful outcomes of 3 divided by the total outcomes of 12. Now, I need to simplify this by dividing both the top and bottom by 3, so that will become a 1 in 4 chance of rolling an even number and a head. So now it's time for a practice question for yourself. If I was to roll a normal 6-sided die twice, what would the probability of rolling at least 1 3 be? Try drawing a tree diagram first before trying to answer this question.